coffee. Oddly enough, Nespresso came out with this new size called like ultra mega huge, where it'll actually overflow a normal coffee cup. And the first time I used a capsule with this new size, I had coffee all over my counter. And I promised myself that I wouldn't let this thing overflow, got distracted, and next thing you know, I have this coffee flood in my kitchen. And so that was what I was wiping up before we jumped on this call here. Awesome. I'm working my way through it. I'm not caffeinated yet. So, anyways.
All right, maybe kick us off with some Wayne's World.
Wayne's World? Wayne's World, party time, excellent. Isn't that like all they do?
Yes. Yes. Excellent.
That's all we'll do. You know what? Actually, Rick was supposed to do a bass solo, and he's supposed to be here too, but unfortunately, we have a bit of a skeleton crew to talk about a really exciting topic, actually, which is edge computing, right, guys?
Yeah.
Absolutely. Are we recording?
Yeah, we are.
Awesome.
Be careful.
Awesome.
Rob, the whole time, Rob, what the hell was that? God, that sounded awful. Well,
nice Zoom background, huh?
Hey, man, this is real. This is real, man.
So real.
How can you prove that it's real?
I guess I'll have to walk into the water, to prove it.
Well, you have
a new 3D,
so it's got to be real, dude.
I can walk out onto the pier.
The new 3D Zoom background.
Yes. Luckily, I've got LTE on my iPad, so I'm good to go.
Oh, that's awesome. Out in the middle of nowhere.
Absolutely.
We're connecting.
Yeah, I'm on Lake Chelan in eastern Washington.
Oh,
nice.
So last week I was further north on the Columbia River. So this week I'm just on a big lake that's really popular in the state of Washington in the summertime. Lots of people skiing and stuff.
So
wave runners.
So speaking of edge computing, it looks like they have edge computing out there.
A little bit.
Yeah, with that delay, maybe they need a little bit more.
Yes. We're caching.
Okay, so edge computing, there's a lot of hoopla about it. What is edge? What is the edge? What is edge computing? Have any thoughts there, guys?
Yeah, maybe. All yours, Rob. You're the expert on edge.
I used to think I knew what the edge was, and then I found out that there's many edges, apparently.
Mm-hmm.
I used to think edge, like if you think of it in the industrial applications, was some kind of industrial gateway thing, a ruggedized deal. It could be in a factory, and it might have a bunch of on it, like for serial ports and stuff to talk to PLCs or other machines, and it would aggregate a bunch of, the edge is always about trying to be closer to the data, right? Closer to the source of where the data is coming from. And so early on, just from doing industrial stuff, it seemed like the edge was this kind of gateway looking thingy that was inside a factory. It could be near a bunch of machines. It could aggregate stuff together. Sometimes it was just dumb, like a pass-through, like if we think of a Cisco router, routing stuff from inside a building out to the internet. And I think that's where a lot of it started. And then people started putting a little more intelligence into those, trying to do maybe some, I think baby steps, starting out with basic filtering.
Mm-hmm.
If I've seen this data point before, like 1 second before, let's just drop the packet. And, so it started with filtering, and then maybe some routing, and then just started growing in intelligence.
Mm-hmm.
At a higher level, though, because I talk to people who have all kinds of opinions. If the microcontroller or the compute that you have that's embedded in your machine, whatever that machine is that you're getting telemetry from, if it has enough capability, storage, compute, RAM, networking to do its thing there, then it can be intelligent there. You always hear the example of video surveillance or whatever. Let's figure out the stuff right there in that machine, in that video camera, in the compute there, rather than sending all the data back. Was there a person in this frame or not? Now, all that said, you probably heard of the fog, which Cisco championed big time, which was big, going from these little edge gateways to maybe bigger servers that also could be either in the factory or nearby in a data center.
Yeah.
And it was like a continuum until you got to the cloud. In the telecom world, the edge is new to them. And they started talking maybe a year and a half ago about something called mobile edge computing, or now they're calling it multi-channel edge computing. Especially around the time we started talking about 5G, and we started talking about putting more compute applications in base stations, either at the bottom, at the base of a cell tower, inside metro data centers. But places to do compute and add intelligence and do things along that pathway, assuming you're using cellular, from whatever your machines are going out, it's all about lowering latency. A lot of times people talk about the edge, it's like closer to the data, get the answers to my questions faster. If I'm on the LAN, I'm doing it. That's the fastest. If I'm leaving my building and heading out, I could do it somewhere at the edge of the cellular network. And that's still going to be lower latency and faster than waiting all the way until I get out, into the open internet and out to a distant cloud, Azure.
But would you consider that edge? Would you consider that as edge computing?
Personally, I did not used to consider that, but they've been giving me lots of Kool-Aid, and I've been drinking the Kool-Aid, so.
I think, well, number one, so multi-access edge computing, right? So what they're calling MEC, which evolved from mobile edge computing. So I think the idea of edge computing is actually very familiar to a lot of folks, simply because it's familiar. It's been there for a long time. And now everyone seems to be getting excited about it, right? And the whole idea of edge computing has been around for a long time. It really started off with the CDNs trying to figure out how do we get content closer to the subscribers of the users that consume the data, which is almost like the opposite. That's like the downlink version of what you saw in the IoT world, or the IIoT world, or the machine-to-machine world, where that's all like uplink stuff, right? You're trying to get data from all of these different endpoints to an aggregation point, right, where you're doing an analytics. So what we're seeing with edge computing with IoT, I think, is an evolution, this continuum of computing that's being pushed out from the cloud data centers out to these quote unquote edge compute nodes. And I think another big thing that's happening, especially with telco edge, if you will, is this whole move toward cloud native, taking these cloud technologies and business models and then trying to figure out how to push it out the edge, which is really not going to be all that easy. I think there's a lot of folks going around, like people were going around in the early days of cloud saying, hey, look, I have a solution that will beat the 900-pound gorilla in the room. And the fact of the matter is no one's really good at this stuff. No one really owns the whole stack. And it's really different from running a data center or a centralized cloud. So one of the big questions is how do you scale these types of infrastructures, especially for macro IoT use cases and applications versus, let's say, some of the more localized stuff, right? And so you see all these different versions of edge, There's like a thin edge, there's a squishy edge, there's a thick edge, there's a near, far, way over there edge, and more variations to come. And so it's really, really confusing landscape that I think is really similar to what we saw with the cloud in the early days and what we continue, frankly, to see with cloud. In a lot of ways, edge computing is becoming an evolution of cloud computing.
Well, I just threw up in my mouth.
Oh, no. Did I fill you up with like...
I think it's complementary. It's I think, you nailed in a lot of sense, your definition of edge computing, Leonard. But I think it's very complementary. So I'm starting to see a lot of projects where edge is complementing the cloud. So it's not just cloud versus edge. Let's stream all the data. Let's uplink all the data to the cloud versus let's keep everything on the edge and make all the calculations there, even access locally in every industry, things like that. I start to see like hybrid versions where there is the cloud and there is the edge, and they for example, you can see if you can save money, for example, with transmissions. Because you have some edge computing, like as Rob said, filtering data, or just applying some algorithms that can make simple or that can, aggregate data and send aggregated data to the cloud, etc. But on the other hand, there are on IoT there is no silver bullet. So there are projects where it makes sense to have edge computing. Others. It makes no sense. For example, on logistics. So if you have a GPS tracker, does it make sense to have edge computing there? Or you always need a gateway to have like the edge computing? There is no like a silver bullet. So for example, now it's getting trendy. Look what I have here. I have
that's it.
So this is a TPU, a USB accelerator for video processing made by Google. This is the Coral TPU accelerator.
Cool.
So this enables to do edge computing now with video streaming and not locally on a Raspberry Pi or boards like that.
Yeah. It's interesting you say that though, but I kind of make a distinction between endpoint computing and edge computing. If you bundle in all the edge stuff, the endpoint stuff, which is the intelligent camera, right? So intelligence on device or your smartphone, then, it's like literally everything becomes edge, which completely overloads and dilutes the concept. And that's one of the big flaws that I see in the discourse around edge computing. There are these different folks in different domains that have been dealing with these architectural patterns as well as problems in the past, now coming together and then confusing each other. And then, especially for the folks in the IoT world, they're used to thinking of like endpoints in a very different way and looking at computing architectures in a very different way. And so when you have the folks in the IT world and the telco world listening to these guys, they think that, oh, okay, well then you mean all these endpoints are also edge computing. And so, it becomes a meaningless conversation, and you can't say anything, right?
It really has muddied the waters. I agree. When everything's the edge, then nothing is the edge.
Yeah, and that's the biggest problem that I see, given that we cover IT, CT, and we cover OT. It's interesting to be part of these different conversations and to see how things are kind of coming together. They're not really coming together, quite frankly, but that's a huge need because people are like talking past each other,
Yeah. Yeah. A lot of analogies people used in the past, especially if you're older, like when we started going to cloud computing in the, 2000s with the AWS, just baby steps, S3, and then going on, and then Azure came along in 2010. Yeah. People are like, oh, wow, the pendulum swinging back to the mainframe model. where we're all a bunch of terminals connected to some distant compute resource. And, we had broken away from that. And so there was always that cloud is the mainframe. And now you're seeing this edge pendulum. And that reminds you of the PC revolution when IBM and Compaq and Dell, disrupted and disaggregated the mainframe and put compute power on everyone's desktop. And that's kind of ruled the day, actually, ever since. And then just getting smaller with smartphones and now compute. And so there is that notion of that swinging back. I also want to just talk quick about architecture, just to make sure our listeners know how difficult edge can be. So one thing, edge is the default location. Let me just say that, because a lot of cloud people say the edge is an extension of the cloud. Wrong. The cloud is the cloud. Edge is where it all begins. It's just like having compact computers running Lotus 1-2-3, baby. It's the default location. It's either where or near where the data is created. And if you have the compute, storage, networking, analytics to do the job at the edge locally, you can do it. And you never have to visit the cloud. Just like critical decisions that I had to make with Lumada and Hitachi doing industrial IoT. Hitachi makes nuclear reactors, bullet trains, stuff where the data doesn't leave. It's not going to you don't want to connect a nuclear reactor to the internet. That's a great way to get fired and get hacked. And so all the compute had to happen there. We had to make Lumada an edge capable thing. It ran on Japanese bullet trains and made decisions locally on the train in motion. And so I think that's where I got real religion on the edge and how important it is, because it just depends on the use case, right? Every customer is different. Every, right tool for the right job, right?
Right. But Rob, one of the things you have to keep in mind is your applications are starting to look different too, right?
Yeah.
You're having a combination of both the uplink and the downlink type of stuff, where before the challenge with, M2M and stuff was more of how do we get the data from the quote unquote edge. Now you can push things to the edge, either in volumes, because now you can have much more richer functions and capabilities that can be supported out the edge. And the other thing is, speaking of architecture, you're making a great point, because all these different options are becoming available to developers to architect solutions in very different ways. And that's really, I think, the big thing. And your point about the pendulum swinging, you're right. It's coming right back down to the middle. And we're coming to this moment where we're realizing, look, cloud is not going to eat everything, or the big centralized cloud's not going to eat everything. You're going to have this nice edge cloud in the middle that's going to do all kinds of stuff, like, all the consumer video kind of stuff, the VR, AR, which everyone talks about, and IoT as well at the edge. And then all this industrial edge stuff that's going to be supported by this big squishy thing in the middle between the cloud and endpoints. That's the big aha I think people need to come to terms with, but also recognize that this big squishy thing called edge cloud is immensely misunderstood, highly complex, and very few people outside of CDNs actually know how to operate these things. Not even the telcos really have a good grip on, number one, how do we operate these things, and how do we actually monetize on services that you deliver on top of those new cloud infrastructures, that's the going to be the challenge of the next decade, honestly.
One thing I want to throw out there too, if a customer is wanting to do edge compute around IoT, for instance, there's another word that's important to look for, and it's the word orchestrated or orchestration. It's not enough. There's a lot of people jumped into the edge thing. I certainly, when I built the Moab thing at Enterprise IoT, and even what I've got today, it's a small node edge thing to run right out at the edge. And it's not enough to have that. There's some great open source technology that'll help you connect to industrial things and do some stuff and then send you back to the cloud. But what you really need is an orchestrated edge compute. And let me tell you what I mean by that. The edge is harder than the cloud. If I'm building a cloud application, it's like this one-to-many thing. Yeah. I've got my one cloud and my one app, and I say, everybody in the world, come visit me, and then I'm going to do compute and processing, and magic stuff's going to happen. If I'm doing edge, I'm going to push out thousands or tens of thousands of little edge nodes all over the place. Mm-hmm. This becomes a problem, and this is where orchestration comes into play. So you may still have this cloud orchestrator node, whatever, that manages these thousands, millions of edge nodes. It's got to know all of where they are, their security, where they push them to, and then you need like a central location. It's like, okay, I'm going to create filtering or analytics stuff here, and then I need to push them down to those edge nodes. Mm-hmm. And they may all, some of them may all be the same. Lots will be different. I'm talking to different kinds of machines. The schema of the data coming at me from different machines obviously looks different data types. And so you're juggling lots of distributed stuff, which goes back to when we went from mainframe to PC. You know, we went to this distributed model, and so it's more complicated. It empowers at the lowest level, which is great, but it's hard. And so it's hard in industrial, and then this whole mech thing, you absolutely have to have an orchestrated edge story. If you're going to be, can you imagine, like you hear the stories around mech, like lower latency for video games or lower latency for all kinds of nodes. I'm going to have to be able to know where and when and what to push all that stuff out and know exactly what's going on across. Can you imagine all these millions of nodes and base stations at the bottom of a cell tower all over the world?
Location.
That's a chore.
Location.
Yeah, and so absolutely. So you have to make sure when you look at these different systems that are out there that do edge, that they're not just some little edge box node.
Right.
It needs to be a fully orchestrated thing that starts from the server cloud out to the nodes and manages all that for you. And I hate to use the term single pane of glass, but you've got to make it easy for your administrator to manage all these nodes everywhere and what they're doing and what are they solving problems there? Are they getting errors? Are they cascading it back up to some kind of cloud? You know, it's a mess.
Yeah.
And so,
yeah, and actually something that is undervaluated, I think, on the IoT, and it's related with what you say. It's a firmware upgrades over the air. Now that it's actually really relevant on the edge computing as well, or not the edge computing. No, this is something that I'm doing now on Balena. But before, I had a lot of problems with some customers that they didn't have enough memory to do firmware upgrades over the air. So now I realize here at Balena that we help a lot of companies to have like an edge computing in place, and in case that there is any bug or anything, in a really quickly way, you can deploy to all your fleet of devices automatically in a really simple way, new firmware, new code, new application that makes your device not a brick or whatever. And that's as well really important, and probably it's something very undervaluated on the IoT, and it's that your devices needs to be easily managed and deployed by your company.
Yeah, but look, Marc, don't you sometimes, when you hear the term edge computing used, don't you kind of scratch your head going, we kind of already do this? And I hear that the most from people who do IoT stuff, right? And a lot of that reason, I think, is because the way that edge computing is talked about today is really from a service provider's perspective. So, and this kind of goes to this whole topic of scaling out and scalability is what is if you're an operator, yes, you need to scale this thing, you need to orchestrate it, you need to be able to have a global or a large footprint to provide your services, to compete with other service providers, right? But if you're an enterprise, maybe you don't care about that. Maybe your implementation, the solution you're trying to implement is very local. And so edge kind of looks like on-prem, and then on-prem becomes then, edge. It's kind of weird, right? So don't you feel some of that conflict like Luke Skywalker did when his Darth Vader faced him and told him that.
Yeah.
Actually, I haven't seen any IoT deployment or edge deployment that where the data stays only on the edge and never leave the edge. Probably it exists and I don't know it. Yeah. Maybe on industrial or what Rob explained, no, on specific industrial use cases. You can find these examples where the data never leave the edge. But anyway, you need like a big memory to store all the data. Usually what I have seen, but this is my experience, and I'm not talking about operator point of view because I never work on a telco or an operator. So I'm usually talking from the perspective of a customer, no, that okay, I have a company and I want to deploy thousands of sensors, no, and why edge can help me? And at the end, it's a matter of, it depends. So let's imagine that, you have CCTV cameras. What is cheaper to analyze? So to upgrade the hardware locally, on all your CCTV cameras. So that means that introduce like a multi-$100 device on all of your CCTV cameras, or actually upstream all this data with with Wi-Fi or Ethernet or 4G or whatever to a cloud and analyze and apply exactly the same algorithms but in the cloud. Now, what is cheaper? Yeah. And I think this is actually what companies that are getting into the IoT are analyzing, or are getting into a balance. Like, what's better? What's the best choice for me? Then, if there is a telco or an operator that prefers to go into a flavored IoT solution and push this company into one solution, that's another story. But
yeah, you're right. But it's always important. My biggest thing is always economics.
Yeah.
And so no matter how cool the technology is or whatever, economics is going to be number one driver for customers. Yeah. And so to your point, if the cost is right, doing compute at the camera, great. If it's better at the cloud, then they're going to do that. A good example of edge compute that maybe it's great to talk about, and probably the ultimate edge platform, is the Tesla car. It's a moving computer, and it's sending telemetry, but it's doing a lot of onboard stuff, right? Because that's part of the deal with the edge. It can't always just be a pass through to a cloud. Yes, the Tesla sends tons of telemetry back home, back to Elon, because it's doing lots of machine learning. It's learning as it drives from all its sensors and stuff to make it better for its automatic, autopilot stuff. But when you get to that automated cars, all that compute, all the decision making happens locally. It does not go out to a cloud because there's no time. You always hear those examples of, I'm about to get in a wreck based on, I'm getting sensor data from a car that's about to hit me. Should I go to the cloud to determine if I should deploy the airbags? Well, that's ridiculous. And so that's an example of how empowered edge compute really has to happen. It's got to make decisions locally. Yeah. And so something like a Tesla has an incredible amount of storage and compute power locally. And it's just a great example. It's an example of why Tesla is so far ahead of everybody else.
Yeah.
It's learning every day from every car.
And actually something that is exciting me a lot about edge computing with Tesla and actually Amazon as well, it's these new projects that probably are still not public or they are working behind the scenes, where they plan to run algorithms from third parties on the edge from another device. So let me give you an example. So I'm driving my car, and I need to and my car needs to do some calculations and don't have the CPU thread to do this calculation. So maybe the car next to me can do it. So I can send the data to the car next to me and get the results straightforward, for example. Or actually, what I heard about Amazon purchasing that supermarket. What's the name of the supermarket that was acquired by Amazon a couple of years ago?
Whole Foods?
Whole Foods. Yeah, actually, it's because they wanted to put data centers on Whole Foods in order to enable that. this edge computing. Well, they call it another name. They're probably marketing people. Yeah, it's better than me on naming, but I see that as like these. Say again, sorry.
Cloudlets. Cloudlets are little
whatever.
edge computing data centers that host edge clouds.
So actually, that idea actually, it's really it's
why
it's
not?
really interesting how third-party edges can compute my edge data.
Yeah, well, you know, they have a lot of that peer-to-peer stuff. So in addition to the quote-unquote edge computing stuff, you also have device-to-device, right? Like to the C to X type of, or V to X type of stuff, vehicle to everything, or everything to everything type of communication.
Yep.
And then new federated models that people are thinking about. So yeah, you're hitting on a lot of really great stuff, but ultimately you guys are, absolutely correct. It's all about economics, but it's about changing economics. And, we touched on our last discussion about the silicon, and it's about how things are getting cheaper. It's getting easier to get inference on device. So, starting with the smartphone, we had, Apple basically incorporating AI to kind of filter through an image, facial recognize folks in your Photos app. Now you can do that on a microcontroller at the edge, or even a intelligent PLC. So, and this is getting cheaper and cheaper. So the tricky part here is figuring out, okay, where are we on this economic continuum of what's possible and what makes sense? Because that continues to change. And for architects, it's a real crappy situation, because you have to be really on hit with where technology is, where it's going, how quickly it's going to mature, and how the economics are going to play out. So that, you want to talk about mind-blowing stuff. You look at the edge and how large this continuum is. There's a lot of decisions that need to be made, but you also need to know a lot of stuff that's probably outside of your domain of understanding to really come up with the best decisions. And what I find is typically IT folks don't know about the OT stuff or the CT stuff. And the CT folks are still trying to figure out the OT stuff. And they're really not that great at IT either. They're trying to do that with all their telco cloud and digital transformation for telco. But that's, I think, the huge opportunity for Edge is to help people figure all that stuff out, because I don't see anyone in all the research that I've done on this topic that anyone really has a great answer, I'm
sorry, how a company can let a telco lead its IoT project?
I don't know. You tell.
I don't know. I don't understand that.
I don't know. It's all about connectivity, right?
That's one ingredient.
But then you're completely locked in. You're completely locked in by that telco, and that's crap.
Well,
should talk about the lock-ins in the future episodes.
Yeah, lock-in's a different story, but I think, Rob, that's the thing. It's not just about connectivity, because it's not about wireless, it's not about wired, it's about everything. And then what you guys have been saying, what makes sense? What's the best architectural decision that is future-proof? Because this crap has to stick around for like 20 years, right? Because no one's going to reinvest in this stuff for a really long time. How do you make it survivable? I mean, put your like friggin' what do you call it? Military hat on and figure out, okay, how do I create a fighter plane that can sit there and take off a runway that has that's been just crater bombed? You have to think about those types of things. And then it's no longer about this fluffy stuff that we've been, the Kool-Aid that we've been drinking. It's like, how do we make this stuff?
Yeah.
Who the hell's going to answer that question for me? And we're not.
I'm going to answer it.
Yeah, you. And you.
I was born in the Edge. On those Trident submarines is a great military example of distributed command and control at the highest level of potentially disconnected remote objects that may still have to make decisions, serious decisions, like turning the missile keys and stuff like that. Getting, from command authority, to release your birds, that kind of thing, that only comes from the president. You've seen the movies, you've seen all the weird scenarios where, and it's interesting. There's so many parallels to that, on a submarine, because connectivity was so critical. You're not connected. You go to periscope depth and put up some antennas to get connected. You are at a certain, maybe shallower depth, and you release this floating buoy that streams out from behind the submarine to have an antenna float closer to the surface of the ocean to pick up signals. And in the scenario where you're really deep and you don't have anything, there's this super, super ultra low frequency stuff that's like a subwoofer in your stereo system, where we've got some giant antennas that are firing signals towards the center of the earth, and then those messages float upward from the bottom of the ocean to the submarine. But it's a great analogy. It's a great edge analogy of the criticality of communications, any way you can get it, but also local intelligence and reasoning to make decisions in a scenario where you're not connected to your larger command authority in the military chain of command.
You nailed it, dude. You have to watch Greyhound, that Tom Hanks movie.
I loved it.
You watched it? Yeah, I was thinking exactly that. What you just said, I was like, I was putting myself in putting the hat of the German sub-commander on, thinking about, well, geez, what do you do in these, it's remarkable how they operated in extremely constrained conditions, right, and situations.
And so you got a bunch of edge compute submarines and ships out there trying to get across the Atlantic.
Yeah.
And your software intelligence is Tom Hanks, and all that crew. But it's based on experience more than anything. Of what have you seen? What were you taught? The submariners back then are being opportunistic. They're just trying to sink shipping to cut off supplies from Europe. Yeah. Not as much strategy there. Just find and blow up. Whereas the other folks are having to be a little more strategic. Yeah, it's crazy stuff. But these are all great analogies when you think about edge computing. I need intelligence. I need to be reasoning locally. Yeah. I may not be connected to a more powerful computer in the cloud, and that's got to be okay.
Yeah, and you have to be resilient. You have to be self-healing. You have to be able to orchestrate and reconstitute the system, because if a certain area of the ship gets hit and certain critical people get taken out, right? You have to figure out how to continue to fight when we have certain parts of the status quo that no longer exists. So how do we reconstitute?
Yeah, how do you bring, like you said, the resiliency? How do you bring compartmentalization to edge compute like you have on a ship? It's all watertight doors and compartments. So part of it can be hit and taking on water, but the watertight doors are sealing that part so that the ship can keep fighting. How does your edge compute keep going when, and that's when I got started in building mobile stuff. That was the big thing, especially when we were just doing GPRS. It's like, you need to build apps that are designed to thrive in a miserable, horrible, inhospitable scenario where things are failing all the time and connectivity is coming and going and there's not enough bandwidth. And it's just like, all our cloud computing was learnings from going from ultra high-end compute technology that telcos use to using cheap disposable PCs where you assume failure and you make it resilient through software.
Yeah, well, there's a reason why we still have pilots in the Navy operating those F-22s or the F-35s off of the fighters, right? And we don't have drones after all these years. So, hey, I actually made it through that mega Nespresso dose of coffee. Isn't that amazing? So I need a refill. Guys, it was awesome. Really, really great.
Yeah. Great discussion.
We'll have to hit this topic again simply because I know that Stephanie, who wasn't able to join us, as well as David and Rick, are going to want to, have their say on the topic. So for all of our listeners and viewers, thanks for watching this episode. And please go to our YouTube site and channel, which is www.iottalk.com. Please subscribe, like, and share. And we'll see you next time. Thanks. Thank you, guys.
Okay. Have a good day.
Adios.
Bye.